So we're going to be focusing on these alpha beta unsaturated carbonyls for the rest of this little section. So let's just review how we create these alpha beta unsaturated carbonyls. We have two main methods. The first is the acidic alpha halogenation, followed by an E2 reaction, usually done with pyridine. So what we have here is some kind of carbonyl. To this, we add some acidic water and some Br2, and then that'll do that acidic alpha halogenation. So that'll do this step. It'll insert your Br in the more substituted position. Right, and that's that first step. And then in the second step, we add some kind of base, usually pyridine. And that'll do an E2 elimination. So it's going to grab that beta hydrogen, form an alkene, and then kick off the bromine to form our alpha beta unsaturated ketone. The other main way we have to form these alpha beta unsaturated carbonyls is our aldol addition, followed by the aldol condensation. Oftentimes, you'll hear the whole reaction being called as an aldol condensation. So what we have here are some kind of aldehyde or ketone. We add some sort of base, and depending on what your product is, you may or may not need to heat it to do the condensation part. And then remember what happens here is that the base transforms this into an enolate, and then it reacts either with itself or with something else, depending on your reaction conditions. But this kicks down, kicks over here, kicks up. Proton transfer just to protonate this oxygen up here. And then we have our condensation. So we have another molecule of hydroxide come in, pick this proton off, form an alkene, and kick off this OH, essentially doing an E2 elimination to get our alpha beta unsaturated, in this case aldehyde, but it can be ketones as well.